We are here to watch our Schmid Innovation in Large-Scale Biomass Boilers. And we will be getting started in just a moment. I'll turn it over to Marcel. But first, just a little bit about Froling Energy is that we are a mechanical contractor focused on the installation of high efficiency, low emissions, commercial biomass boiler systems. And we do work in schools a great deal, a lot of retrofitting. It seems to be a place where the biomass has become very well accepted, especially up in the north country, the rural areas of Vermont and New Hampshire. There's a tremendous amount of schools that have been converted and continue to be converted. There's commercial buildings. This is an old mill in Peterborough in that picture, and then industrial buildings, which is Whelan Engineering, which we're offsetting almost 200,000 gallons of oil a year from what they were doing, and we're using our dry wood chips there. And also multifamily buildings and homes. We've got a number of installations that way. We're a self-performing contractor, which means we handle pretty much whatever has to do with a boiler system, perhaps into distribution. But the key is that we'll come in, and if you need a new boiler building, if you need to have some piping run, and obviously things like silos and the boiler systems themselves will take care of all of that. Concrete. In this case, you can see that silo and the boiler building in the background there. We built everything there. So put in the concrete and did it all. So lot that we can do. And the system commissioning, obviously, and working with backup boilers as well. All of that can be done. If you're an engineer, an architect, a building owner, and you'd like to have a project feasibility or design, we're very happy to talk with you. And we're also fairly familiar with things like grants and rebates that are out there, and we can help you with that as well, because very often that's what will help to move a project forward. We also are manufacturers of PDCs, which is our precision dry wood chip. It's an in-between fuel between pellets and green wood chips, and it gives you a better value overall, because it's a less costly than pellets by as much as 50%, and it's a good quality fuel that can be blown into an above ground silo, so the infrastructure that you put into your site is less costly, because it's all delivered by blower truck. So today, again, Schmidt's innovation in large-scale biomass boilers. If you've got questions, we'll be answering those at the end of the presentation. But there is the chat bubble there you can find if you scan around. Usually it's at the bottom of the screen. But you'll be able to enter in questions. We'll cover those later on, and perhaps we'll open up the microphones as well so you can ask directly at the end. So today, our speaker is Marcel Danuser, who is the head of export sales. And he's been with Schmidt for 8 years. He started out in project management, working with a number of different big projects that they were doing around the globe. In that, he became very acquainted with a wide variety of business areas and different types of clients, in manufacturing, hospitals, food processing, district heating, institutional organizations. And it gave him a profound understanding of the technology and the industry overall. And in 2016, he moved into the global sales area. And just a year later, he was selected to lead the sales team for global sales. So along with leading the team, his main tasks are to take care of existing partners, to build up new markets and to establish new distribution partners, and to refine the worldwide sales channels so that the new boiler customers can find the right solutions, both technically and commercially. So I want to welcome Marcel Danuser, who is going to be giving the presentation. Welcome.
Okay, good morning to everybody, and thank you very much, Jim, for this nice introduction. First of all, a big compliment to you and Froling Energy, making it possible with these webinars to maintain the active exchange of information within the industry, as well as with the customers, despite these difficult times we're in. For almost a year now, this has become extremely challenging, especially in an international or intercontinental context. It is therefore a great pleasure for me to talk today about the Schmidt company, its products, and the European market requirements for about the next hour. The agenda for today, I will start with some facts and figures about the company, giving you an overview of the product portfolio. And then, as the core part of this presentation, I will outline the customer benefits of using a Schmidt boiler, especially in terms of profitability, because at the end of the day, this is the most important thing for most of our clients. After that, I will quickly show some slides about trends and developments in Europe before I will finish my presentation with a showcase from Switzerland, pointing out how the previously mentioned solutions can be applied in practice. As Tim already mentioned, if you have any questions, I'll be happy to answer them at the end of the presentation. Good. Now, before we start speaking about the technology, some words about the company. Schmid is a family-owned company existing since 1936 and run in the third generation. So it's already more than 80 years now the company has been producing wood-firing system for industrial, commercial and residential applications. And if we look back in history, the company Schmid, and above all, the former CEO and owner of the company, Hans-Jörg Schmid, have played a crucial role in shaping and establishing the biomass heating industry in Switzerland and neighboring countries, making it what it is today. During all these years, Schmid was able to grow continuously and today employs about 300 people globally. Schmid Energy Solution is not only #1 boiler producer in Switzerland, but also very active worldwide. The company has 9 subsidiaries in Europe and many strong partnerships around the globe, such as Rolling Energy in the USA and others in Asia, Europe and America. The headquarters of the company is in Switzerland, while the production is based in northern Poland. Today, Schmid produces about 70 to 100 industrial boilers per year and about the double amount of domestic boilers. In total, more than 3,000 industrial and more than 4,000 residential boilers were installed worldwide during time. Speaking about the boilers will lead us to the next topic, the product portfolio. Product-wise, we have 2 different lines divided in 2 different business units. Industrial systems include wood combustion systems with a capacity of 180 to 8,000 kilowatts. As a source of energy, a large number of biogenic solid fuels can be used. By the way, you have the equivalent numbers in BTUs in the slides. Domestic or residential systems include wood-firing systems with an output of 15 to 240 kilowatts. The energy carriers here are logwood, pellets, or wood chips. Today's presentation will focus on the industrial products, but nevertheless, I would like to give you a quick one-chart overview of our domestic portfolio also. On the domestic product portfolio, you will find 2 different logwood boilers. Here the left one is for half-meter logs feeding from the front, and the right one is for half and 1 meter logs feeding from top. Especially farmers with own forest, for example, like these products very much. Then the UTS-D on the right side can be used for either pellets or wood chips with a capacity up to 240 kilowatts. All these products are Schmid-owned products, but unfortunately not yet available for the US market, as they are not ASME compliant. Now we are going to have a closer look to the industrial boilers, which are UTS-R, which is a horizontal moving rate firing system. Then in the middle, the UTS-K and UTS-P, underfeed stoker, or also called retort firing systems with an active burnout rate. And then on the right, there's UTS-W, which is a water-cooled step-grade firing system. Next slide, please. UTS-R is our flagship because it can burn wet and dry fuel from 10 to 60% moisture content. It is available the whole range of capacities up to 8 megawatts. The counterflow firing system with horizontal moving grate is space saving. The combustion chamber is air-cooled with the grate frame, and the grate frame is water-cooled from 700 kilowatts onwards. The UTSR can be equipped with all available options in order to get highest performance and best comfort. Next chart, please. UTSK is for wood chips and UTSP for pellets, but the principle of both boilers is an air-cooled underfeed stoker firing system with active burnout grate. The UTSK can digest good quality wood chips up to a moisture content of 50%, while the nominal capacity is guaranteed up to 45% moisture content. These boilers are available from 100 kilowatts up to 900 kilowatts. UTSW is a step-grade firing system with a fully water-cooled combustion chamber and also water-cooled grate bars. This machine was developed for the valorization of alternative fuels with higher calorific value and low ash melting point, as in example residues from agriculture or food production. The UTSW is available from 300 up to 4,200 kilowatts and can handle a moisture content ranging from 8 to 44%. And then, of course, we can customize the firing systems according to clients' needs with different heat exchangers, meaning with different design pressure levels for hot water or also for steam applications. There we limit ourselves on the standard portfolio on 16 bar operation pressure and a capacity of 11.5 tons an hour of steam output. So this was a rough overview of our product portfolio. On the next few slides, I want to focus on the customer benefits and what is needed to have smiling clients like this guy here on the picture. Not just after a successful installation and commissioning of the plant, but also after many years of operation. Every single installation is a customer reference. This is a Schmid guiding principle, which is also lived out in this way in the company. So what keeps the client smiling? What is important to them? We think that most of our clients expect the following things from a biomass firing system. It should have reliable functionality with long service life, efficiency in operation and maintenance, safe and clean operation, meaning no troubles with authorities, good after-sales service, means quick and competent help when needed. All this has a significant impact on the profitability of the plant. And profitability is energy sales price minus full energy generation costs. The energy sales price is somehow given by the local energy structure. There is not much we can influence here, but the full energy production cost must be as low as possible to achieve a high profitability. The full energy production costs include CapEx and OpEx of the plant, while the operation expenses usually have the far greater influences on the profitability, as the lifetime of such a plant is usually calculated with 15 to 25 years. As we have many heat contractors among our clients, running usually between 20 to 30 biomass plants, and I can tell you they measure almost everything in order to find out where money has been spent or lost during the year, we are very keen to keep the OpEx of our products low. So how can we help the client keeping the operational costs low? First point, reliable functionality with long service life. This can be achieved by a professional and smart plant concept, meaning the right dimensioning of the fuel storage and transport system according to the fuel specifications and the capacity of the boiler. Then dimensioning of the boiler size, considering year-round heat demand with regard to the minimum part load during summer operation. Avoiding stop-and-go operation by using buffer tanks and or double boiler concepts, and also consideration of maintenance excesses and planning of redundancy on critical parts if needed. Then very important, choosing the right quality of the boiler system, of course. This can be done, for example, by comparing the following main quality features. Grate rating, which is capacity per square meter grate surface, or furnace rating, capacity per combustion chamber volume, is an easy one to compare. But also the weight of the furnace gives you a very good indication of the quality of the product in terms of thickness of the concrete lining and the steel plates. Just ask your supplier for these figures. Also, heat exchange surface is an easy one to find out about the quality of a product. Make sure you are comparing apples with apples, because some try to make themselves better than they are actually by exploiting unclear definitions to their advantage. As the heart of every biomass firing system, the combustion quality has a significant influence on the wear and tear, and thus the service life of the furnace. For a good combustion, it is very important that the capacity generation take place in the secondary zone, which results in low thermal stress of the combustion chamber and the grate bars. Here with the gentle, low wear operation can be ensured. Furthermore, an efficient, stable and low emission operation at constant low oxygen content in the exhaust flue gases can be achieved with continuous movement of the grate. We are going now to see a short movie showing what is important about the good combustion, and especially how does it look like. So please keep special attention on the fire behavior. For your information, there will be no sound during the movie, but you'll have the subtitles in English. I will not say anything during the video. But please, Jim, start the movie, please. Okay, so I hope you had a better quality than I had it here at my end in Switzerland. Was not very smooth, but yeah, I will mention the most important things again here. So lighting a fire and generating heat is not difficult, and people having been using it for thousands of years, but controlling the fire and letting the heat come out exactly where you want it to be, and at the same time keeping the emissions low and the efficiency high is quite challenging. On the left picture, you see again the different stages of a biomass combustion. At the back end there is the drying and degassing zone, followed by the charcoal degassing and burnout zone, and the thermal power production taking place in the secondary zone, into which oxygen is blown and thus causes the pyrolysis gases to burn. For comparison, on the right picture, you see a fire which burns on the grate. It looks nice and cozy, but you can clearly see the energy generation is not happening at the right place there. Next chart, please. One chart back. Yeah, here we go. Here another example of a fire which looks to many people quite nice on the first glance. But if you analyze it more detailed, you will also find the energy production is taking place on the grate causing very hot areas at the places where the most of the primary air gets through the grate. We call it also hotspots or volcano building. When it happens at the wall side, look at the red circle, not just the grate bars have high thermal stress, but also the wall can be damaged, which we'll see here in the next slide. This is an example how it could look like after too many hours of too hot burning on the grate with too much primary air. Of course, sooner or later this has to be repaired in order to avoid further damages. But not only uncontrolled combustion can lead to hotspot building, but also stones in the fuel can cause a gap between conventional grate bars and thus open the space for too much primary air supply. And usually after the small stone, a bigger stone goes into the gap, and then an even bigger one goes in. This can lead to a couple of different issues like blocking and damaging the grate and the sidewalls. The Schmid boiler are therefore using overlapping grate bars, so no stone or nail, etc. can get between them. See the picture at the bottom here. What is also, you were too quick. Yeah. What is also special about the Schmid grate is that it is slowly but continuously moving in order to keep the fuel rolling over the grate without whirl it up, with the result of achieving very low dust emissions. Please pay attention to the special shape and movement of the grate bars, which is not only moving back and forth, but also up and down at the same time. Now we go back to the question, how can we help the client keeping the operational cost low? Second point of what is important to our customers is efficiency in operation and maintenance. This can basically be achieved with high boiler efficiency, high boiler availability, and as little labor costs as possible for operation and maintenance of the plant, and low fuel costs. Let's take these points a little further in the following slides and see what Schmidt can contribute in that field. Next slide. First point, the boiler efficiency, as everybody knows, is the relation between energy input and output. The difference between the two is the losses, which must be kept as small as possible. Those losses can be divided into thermal, chemical, and radiation losses. The most significant losses are the thermal losses. Especially the flue gases carry a lot of energy out the system, and a little heat goes also out the system with the warm ashes. The chemical losses are basically unburnt material, which leaves the system as unburnt ash or coal, or as unburnt gases, basically carbon monoxide, CO, leaving the system through the chimney. Then, of course, there are radiation losses on the system and its auxiliaries. What is Schmidt doing to keep these losses as low as possible? Thermal losses in the flue gases are reduced by having a low flue gas temperature per default, which can be lowered even more with an additional heat exchanger or economizer, while the flue gas temperatures should not fall below the dew point in order to avoid condensation and corrosion in the smoke duct system. High temperature corrosion must be taken into account. The amount of unburnt ash is less than 1% due to the sufficiently long burnout rate of Schmidt boilers. The low CO values of Schmidt furnaces show that the proportion of unburnt gases is low also. The result is a high boiler efficiency confirmed by TÜV certificates, which shows that the highest boiler class 5 according to EN 303-5 was achieved with an overall efficiency of more than 92%. Radiation losses are reduced to a minimum with the compact design with attached multicyclone, thick insulation layer and backfeed of the radiation heat by combustion preheating. See more about this in the next slide. As you can see now in the video, the combustion air is sucked in at various openings in the boiler casing and then runs through behind the casing until it's blown into the combustion chamber as primary air. The combustion air thereby absorbs the radiant heat and returns it back to the system. Then next slide, please. On the water hydraulic side, we improved the heat exchanger in order to get the highest efficiency. The implementation of guiding plates forces the water flow to cross the hot flue gas pipes twice at an almost right angle, with the result of an improved heat transfer. As you can see, the compact design here with the attached multicyclone assures a space-saving installation and low radiation losses. Cleaning openings on all sides enable quick cleaning. A powerful blast of pressurized air cleans the inside of the boiler tubes. The air rapidly cleans loose ash particles sticking to the inside of the tubes. Each fire tube has a compressed air nozzle fitted. Periodical cleaning is taking place during ongoing operation. No loss of capacity during the cleaning cycle. Efficiency increase by 3 to 7% compared to polluted heat exchangers. And by the way, it was Schmidt who has invented the heat exchanger tube cleaning system in the year 2000. Unfortunately, the idea has not been patented. Another cleaning option is the radiation vault cleaning system, which is also based on compressed air injection. Pressurized air is blown in at the red dots here, keeping the vault free from ash layers. This system is available for boilers with a capacity from 1000 kilowatts onwards. The automatic undergrade de-ashing means the discharge of the ash, which was falling below the moving grade, with a moving floor system, pushing the ash directly into the grade de-ashing auger. This system is reducing the manual cleaning to a minimum. And if all mentioned cleaning possibilities are installed, a total cleaning by the chimney sweep once a year is sufficient, even with hog fuel. This results in a boiler availability of 97 to 98%, and thus the labor costs are kept to a minimum. The automatic ignition is another feature to keep labor costs low. It allows automatic start and cascade functions without manual interaction. The electric ignition with individual hot air blower is available up to a nominal capacity of 900 kilowatts and a maximum fuel moisture content of 35%. The gas burner version is available up to a nominal capacity of 8 megawatts and a maximum fuel moisture content of 55%. Both propane and natural gas can be used. In the next few slides, I would like to show some of the features of our control system and its user interface, followed by the remote access ability of it. So nowadays, everybody knows what it means having a simple and practical interface to the machine, using different apps every day on our smartphones. With our new clearly arranged and user-specific interface, the operator gets a quick overview of his firing system and of the specific parameters which are of most interest for him. The most important trend and recording data as energy production, different temperatures and pressures, just to name a few of them, can be viewed directly on the panel. Also, different statistical data are available there, as in example, operating hours of the firing system, split it into different load levels, so you get an idea about how heavily the firing system was utilized the past weeks or months. As another example, the amount of starts and stops of the boiler can be reviewed. And of course, the control system also offers the possibility of remote access via VPN client. This ability allows the client having control of the boiler from everywhere via smartphone, tablet, or desktop computer, but also Schmidt and the local distribution partner like Fröhling Energy can access the panel if the client allows. Four devices can actually access the panel at the same time, either via LAN or VLAN. Many operators using a tablet, which they carry on them while moving around the plant, so they can see the effects of their setting changes directly on the machine. This is very handy, especially on bigger plants. But when it comes to the observation of the fire, it can be easily followed on the computer or even on the smartphone from remote using the combustion chamber camera, which is installed on the front door. The times when the operator had to open the door to see the fire is definitely over, as too many times accidents happened through deflagration. A couple of years ago, we decided to even go one step further, inspired by the car industry. Please enjoy the following movie, even without sound, and I will try to comment it. Is something happening or not? There is a car that knows it already. Attentively, it observes its environment and reacts before anything happens. So that was a spot from Mercedes. And so this was also our goal. We don't want unhappy clients having troubles with their biomass heating system. Usually it happens on the coldest day of the year. We want to avoid that something happens before it happens. Therefore, we added to the remote access, which is that slide. Please, the next slide. The automated remote maintenance system, which means the plant data are automatically and continuously sent to a server where they are automatically analyzed. An automatic alarm is created if a value is underrun or exceeded a certain range, which is an early warning. Now the support will keep an eye on that plant, and if the warning does not disappear soon, he will contact the operator to find out what happened and how to fix it. The system can also generate automatic evaluation documents for the client and authorities if needed. Also, various trends and analyses are automatically generated and can be viewed online. Then here's an example of a plant improvement achieved by the remote maintenance system. The running time of the boiler could be extended by adjusting the load level of the boiler and the exploitation of the buffer in order to reduce start and stop operation, which has a negative effect of the durability of the boiler. It has still 6 hours run time and 6 hours standby time after the optimization. But if you look on the left side, starts and stops have been reduced significantly, and the running time between them could be improved from smaller 1 hour to 3 hours roughly. So this is a tool to help preserve the investment of the client, because most of the operators would not have realized that something is not perfectly okay here on their installation, as the heat was always available for them. So before our clients get hit by the big hammer, causing a painful sound in the ears, we prefer to ring a small bell from time to time to protect him from bigger issues. Of course, annual service, preferably with a service contract, is also a good way to keep the system running reliably. Speaking about fuel now, this is a major lever in calculating profitability for our clients, who usually want to source local, low-cost fuel while being flexible of what is available. For every project, the perfect fuel might be different, depending on what is available, the amount of energy production of the plant, and also regional emission limits must be taken into account. But it doesn't matter which fuel the client goes for, Schmid has a suitable boiler for him ready to burn all kinds of different solid biomass fuels. The UTSR, for example, has a very high fuel flexibility, as it can burn from bone-dry pellets to wet hot fuel or pure bark. The fuel determines the transport system, the firing system, the waste gas treatment technology, and it could have a great effect on the maintenance and service costs. Using low-cost fuel means usually higher investments and operational costs on the other side. So it has to be balanced carefully. For example, burning demolition wood containing a lot of difficult elements will require a lot of additional flue gas treatment devices, as, for example, DNOx, DSOx, and continuous measurement, etc. In addition, this fuel will also reduce the lifetime of the boiler and the transport system. So even when this fuel is for free or even paid, maybe the profitability of the plant will be negative due to the high investment and operational expenditures. In Europe, the use of wood chips and forestry wood chips and sawmill residues is the most common in the district heating sector, while the valorization of alternative fuels as agricultural and food processing residues is still rather rare today, but it is likely that these fuels will play a greater role in the future in order to achieve the energy turnaround. Now we go back to the initial question of what is important to the client. We were speaking so far about reliable functionality with long service life and efficiency in operation and maintenance. Now we're going to speak about safe and clean operation and how we can support with this topic. First of all, personal safety is not a nice to have. It must be observed without compromise in all operating conditions. The supplier of a biomass boiler should prove that its machines are safe and compliant with the relevant standards, as the Machinery Directive or the Pressure Equipment Directive or ASME, just to name a few of them. One standard has particularly been created dedicated to biomass firing systems. It is the EN 303-5, where Schmid reached the highest boiler class 5 with its boilers. It contains all kinds of requirements in terms of efficiency, emissions, and safety. Here is one safety example that had to be implemented in order to reach highest safety requirements here. For avoiding deflagration, the front door is locked and cannot be opened unless the combustion chamber has been air flushed and high enough oxygen content is measured. In the unlikely event of deflagration, pressure relief valves serves as controlled pressure release. So it is almost impossible, meanwhile, that anyone gets harmed from deflagration with a Schmid boiler. There are many more things to say here, but this would fill a whole separate presentation. Now speaking about emissions, there are two things here to mention. First, there are regulations and emission limits which have to be fulfilled. Otherwise, you will get into troubles with the authorities, and nobody wants that. Second, low emissions also mean money in some countries, as for example in Sweden, the operator pays for his NOx emissions. It can make some 10,000 euro difference per year between a low NOx emitting furnace and a standard one. What you must know about Schmidt boilers in terms of emissions is that the emissions are guaranteed on all capacity levels from 30 to 100%. The Schmidt multicyclone achieves a high degree of separation. In many applications, no additional filter is needed. And Schmidt has a long-term experience from his home market with high requirement projects with ESP, electrostatic precipitator, wet filters, backhouse filters, DINOX and DSOX systems, also condensation and evaporation systems. Let us have a closer look now on the DINOX system. During the combustion of wood, nitrogen oxide is formed from the nitrogen in the fuel. The nitrogen dioxides, the NOx, can be lowered with the selective non-catalytic reduction process, SNCR. A special and higher DINOX combustion chamber is used for this process. It has holes on both sides where the urea solution is injected by a lens. It's at the red circle in the picture. For chemists among you, I'll try to explain the chemical reaction rudimentary. The injected urea solution plus the nitrogen oxide from the fuel plus oxygen is under the right thermal conditions transferred to molecular nitrogen, which goes into the ash, water in the form of steam, and carbon dioxide. You have the exact chemical formula on the slide. A max reduction of 65% of NOx can be achieved with the SNCR system. Dust filters belong meanwhile to biomass boilers in most of Central European countries, as the dust limits are so low they cannot be achieved without filters anymore. Schmidt can provide the full package, selecting the right filter type for every project. Depending the requirements, a backhouse filter, an electrofilter, or a wet filter can be the preferred solution. The most common filter types for standard applications are the electrostatic precipitators, ESPs, as the operation and the maintenance is very cost efficient. Backhouse filters are used when the dust limits are set very low. Wet filters are usually used together with condensation systems. As the last point of what is important to have happy clients and keep them happy is a professional and close by after-sales service. Because there is only one thing worse than having a problem with the heating system, namely having a problem with the heating system and left alone with it. So the after-sales is very important, and the Schmidt philosophy is to only sell boilers through reliable and professional partners who are able to provide this kind of service to the end customers in order to preserve their investment. Then we go to the trends and developments. Also in the biomass industry, the digitalization is of course a big trend. Everything is connected and communicating with each other. This trend will certainly continue. I'm curious to see what the next few years will bring us in that field. But what we are already working on today is a self-commissioning and self-adjusting biomass firing system that can adjust itself automatically during ongoing operation when fuel is changing from dry to wet fuel, for example. This will allow perfect combustion conditions at all times and thus guarantee continuously high efficiency and low emissions. The current trends on requirements we see on the emissions are low NOx emissions whenever possible without the use of an SNCR system in order to keep the operational costs low. Same for dust. The industry is requiring low dust emissions without additional filtration devices and high filter availability, which brings us to the next slide. Switzerland requiring a filter availability of 90%, comparing the running time of the flue gas ventilator and the running time of the filter when it does not bypass. As filters usually bypass during startup till the flue gases reach a certain temperature level in order to avoid condensation in the filter, we have come up with a boiler bypass system in order to get the filter much quicker warm and thus online. This is just an example of the current challenges we are facing in Europe in order to fulfill the high and higher requirements set by the governments. Before I will finish the presentation, I would like to present a showcase from Switzerland, pointing out how the previously mentioned solutions could be applied in practice. The project I'm going to speak about is the Grindelwald district heating. Grindelwald is located at the foot of the famous Eiger North Face and the Jungfraujoch, which is one of the most important travel destinations in Switzerland. About 1 million tourists travel to the highest railroad station in Europe every year. The village is about 1,000 meters above sea level and has a permanent population of 3,800 inhabitants. During the main season, it is a multiple of it. The heating plant was built in 2009, a bit further down the hill on the right side of the picture below the village center. Here you see the heating plant, where two Schmid boilers, UTSR 3200 kilowatts and a UTSR 1200 kilowatts, were installed together with the 5 megawatt peak and backup oil boiler. Gentle operation is ensured by a 52 cubic meter buffer tank. The district network is 5 kilometers long and supplies 62 customers with renewable energy. Many hotels and public buildings are among them. The heating network runs on 90 degrees Celsius leaving temperature, and 16 bars operation pressure is needed, as there is quite a big difference in attitude between the heating plant and its customers. Looking at the plant layout, the plant has a big silo with a crane system managing and mixing different fuel types as dry waste wood and wet forestry wood chips. The fuel is delivered by trucks and filled into the unloading bunker, from where the automatic silo crane stores it in the passive silo, which is the big silo compartment. The villages, please go one slide back, thank you. The villages have, by the way, the possibility to deliver untreated waste wood free of charge via the chipper line with the magnetic separator. This material then also falls into the same unloading bunker. The crane always knows what kind of fuel it is storing by means of a fuel switch. This means that the fuel can be mixed later when it is transported to the active silo. The active silo, also known as day silo, is basically a moving floor system that conveys the pre-mixed fuel to the two separate screw feeding lines. To the Schmid firing systems, which are both equipped with all the automatic cleaning options and also with an on-top mounted economizer, dropping down the flue gas temperatures in order to increase the efficiency. And ESP is used, by the way, to reduce dust emissions. You see it next to the big boiler on the picture, just a little bit. To increase efficiency even further, a condensation system has been installed. It recovers the heat that was needed to evaporate the water in the fuel. As a result, an additional heat output of 700 kilowatts can be obtained. Under perfect conditions, a condensation system can achieve an additional capacity of up to 30%. On top of that, in order to prevent steam plum visibility in this touristic place, where visitors especially come for the breathtaking view, the flue gases are continuously devaporized. The relative humidity of the flue gases are reduced by the system, and condensation at the chimney outlet can be avoided. This was a strict requirement condition of the municipality. I think this is a good example how to deal with the different interests of a community and find constructive solutions for them, but also showing what is possible to achieve highest efficiency paired with low emissions while using low-cost fuel. Thank you very much for your attention. I hope I could convince you of the reliability and efficiency of our biomass solutions just as much as these shikes in the picture. If you have any questions, I'll be happy to answer them now.
I wanted to say a couple of things just about the emission side of things. Is that every country has different criteria. At least, I think there's probably some commonality in Europe among countries, but there may well be many differences as well. And in the United States, not only do we have differences, but we're measuring slightly different things. We're prioritizing certain things over others. And in this case, we brought the boilers over. We've got a half a dozen installations at this time, mostly burning the dry wood chips. In fact, all of them, I think, but maybe one has a little bit of a wetter chip involved, but most of them have the dry wood chips. And what we've discovered is that we pass our requirements with flying colors without using an ESP, which has been quite good when it comes to return on investment, because they can be easily $250,000 and up to install one of those. And in the end, it ends up being a much more cost-effective installation. So we have succeeded. In fact, we beat the PM 1.0 and the 2.5 emissions criteria, which are the main criteria that we're judged on, with the test on site at these different boilers that are over the 2 million BTU input. Those have been beating the requirement by 50%, and that's utilizing just the standard, either the UTS-K or the UTS-R boilers, using the dry chips. And the one thing about our dry chips is they are screened, so that means there's not a lot of sawdust, other fines within that. And that is one of the biggest differences that we see when we run tests. And we've been able to not only run those tests, but then run some variables within the tests to see what passes and what doesn't and what causes a problem. And it's a little bit of experimentation. You can only go so far on that, but that's definitely what we found is that the fines are the biggest variable that causes trouble. So a screened fuel is a very important fuel in this region. And these are pretty phenomenal boilers, and we decided to try the Schmid boilers, and wow, we've really found some nice improvements, and you can see that they're advancing the technology in many ways. And I think that the whole customer experience side of things is a pretty important side, because the ongoing, we have now, we're maintaining over 200 sites as a cleaning company and as a service company. And that becomes a very, very big, important part of our business, to make sure that the customers are indeed happy after the fact. Oftentimes you'll have a school and the facilities director is there and he's all excited about getting this. Then he might move on and you get somebody new that doesn't really understand it, wasn't really in the enthusiastic phase of implementation. And we need to be there to train them, to get them excited about it, to show them what it's all about. It's a lot of times, older systems were a little more painful to monitor and to maintain. And here, there's not so much to do, but you have to do the right things in order to keep things moving forward, and you have to train them properly. So it's good. Another one of our experiences, Marcel, has been the frequency of cleaning. Some of the earlier boilers and pellet boilers, so forth, that are being used in commercial situations. We find that one of the policies was every 600 hours of runtime, they need to be opened up and cleaned, brushed out, even though they have various cleaning mechanisms. What have you discovered in that, Marcel? What would you say the cleaning time is?
Yeah, first of all, I mean, yeah, we're used to have much worse fuel than your PDCs here in Europe, and so yeah, that might turn out in more often cleaning if you for example burn pure bark, but yeah, of course I mean, especially if you go for all the options for automatic cleaning, then you do just once a year by the chimney sweep. And that is what our big contractor clients aim for. They because labor costs is too expensive, and they don't want to hire a guy removing ash bins and cleaning boiler every day. So this is a clear requirement from the clients here. What we have.
Mm-hmm. One of the things that I had never heard of before was this idea of getting rid of the vapor plume. And it's certainly important in, like you say, the scenic area. And I suspect there's places where a plant is right near some traffic. And there's going to be those certain days of the year you might get a sort of an inversion and the wrong kind of humidity, pressures, and so forth. And you end up with creating a cloud from your chimney that goes out into a road. And that wouldn't be so good. So these kinds of things are, like you say, it's local. It's whatever the site needs and requests, and there's a lot of capability there. And the United States is not really worried so much with these plants having to do with the NOx and the other factors, but those could come along very easily as things that we can monitor and eliminate. And that's something that you can see it's possible. Any other questions? I don't see anybody typing anything in, but we certainly have some time here if you wish to ask a question. Well, Marcel, he's calling from Switzerland, so it's yes, go ahead.
Jim, this is Khaled. How are you?
Very good.
Yeah, thanks for hosting the presentation. Question to Marcel. You mentioned that you have a condensing system that can increase the capacity up to 30%. I didn't capture that. What capacity are you talking about when it comes to that 30% increase? And how would the condensing system increase the efficiency? How many points are you expecting because of the condensing system?
Yeah. Thank you, Khaled, for this good question. Condensing systems need the right boundary conditions in order to be efficient. And that means the fuel must be wet. It must be, the perfect conditions are 50% and more moisture content, and it needs low return water temperatures from the network. And here we're speaking about lower than 50 degrees Celsius or less. And with that boundary conditions, you can reach an additional output of 30% of the installed boiler capacity. So Yeah. For example,
okay.
if you have a 3 megawatt boiler installation, then you could reach up to 1 megawatt additional power with the condensation system.
But if you are getting a 50 degrees centigrade return temperature, don't you need a three-way mixing valve for the anti-condensation, or would the boiler be built differently to deal with that low return temperature?
Yeah, I mean, it doesn't go directly to the boiler. It goes first through the condensation system and gets heated up a bit.
Okay.
And then, of course, usually the boilers, they have the return temperature stabilizer, assuring that the difference between leaving and return water temperature is not too big. So that is usually installed to keep that difference at about 15 Kelvin of temperature difference.
And how many of your projects can actually utilize a condensing system, since it has a lot of requirements? I mean, percentage-wise.
Yeah, it really depends also the region. For example, Sweden is a good area where they traditionally have low return water temperatures. Not so much in Switzerland, as you also maybe have recognized on that showcase project here. The output is only 16% here on the Grindelwald project. It's only 16 because the return water temperatures are around 60 degrees instead of 50. And as you also have seen, the fuel is a mixture between dry waste wood and wet forestry wood chips. So the average, always depending how much they get from which type of fuel, but the average fuel moisture content is around maybe 40, 35, 40, 45. And that has a huge impact on the efficiency of the condensation system.
And is the condensation system also enhancing emissions?
A little bit. Yeah, it's difficult to say how much, but it also washes out a bit of the dust particles and also some NOx. But there's ongoing studies on that in order to find out if it can be used as also as a fuel smoke gas cleaning device. Yeah.
Well, thank you very much. Appreciate it.
You're welcome. Yeah.
Good.
I mean, this would fill a whole other presentation speaking about filters and economizers and devaporization systems. But maybe that can be organized for the next sessions to have somebody speaking about those products a bit more in detail.
Certainly, as we go along, we're going to come up with new topic areas, especially with Schmid, with these larger boilers. So that's a good thing. That's a good thing. I don't see any other questions, but if you have a question, you can speak up. And,
I mean, Jim, I have a general comment / question.
Sure.
In Europe, are they having more strict emission requirements like what the US has done recently with EPA? And I don't know if you foresee any changes with the change of US administration, that there may be more strict emission needs. So we need more, plume treatment. I mean, do you foresee any of that? I'm just thinking out loud.
I personally don't have any input on that. Obviously, we're all sort of with bated breath, wondering what's going to happen here. But there's the changes we expect things like some of the plans that the Obama administration had been looking at for the Clean Power Plan and so forth, and the emissions have been improving. I should say the restrictions have been escalating on the different biomass fuels, but I think in the end we are going to be looking at NOx, and as things become more commonly utilized, I think as part of it too, you can go under the radar for a while until then you realize that you're need to do better as plants are implemented. But I think that these guys are covering, Schmid is covering those future requirements very nicely. And with the, especially with some of the remote monitoring, which is going to help an awful lot as well, because they showed the startup emissions on the slides here, where you end up having this period when it's a very smoky output. Well, to be able to clean that up might be one of the first things we'd have to do. So there's a number of areas that they're confronting, both from the ongoing, when it's burning really hot, what's the emissions, versus when it stops and starts, and so many other aspects of this. I think just a well-running machine, if you can see that remotely as an expert and say, it looks like you're having some trouble here, we need to take a look and make some adjustments. Maybe there's some areas that are clogged or something that need to be cleaned. That kind of remote advice is wonderful, and I totally encourage that. What do you think, Marcel? Anything else?
Yeah, of course. I mean, the very important is having a good combustion, as I tried to show in the videos and in the slides, without moldering and stuff, to avoid having bad emissions. And another thing came into my mind is when it comes to emission guidelines, what we would sometimes appreciate is that the governments would make differences between rural and urban areas. I mean, if you build a plant in the city somewhere, it has to fulfill much higher emission limits than, for example, if it has built somewhere 2 kilometers outside a small village. Yeah, it's almost crazy sometimes to install all the devices there, DeNOx systems and huge filters, when it's just standing somewhere almost in the middle of a forest. So I would wish governments to put different specifications on that areas.
Froling Energy is we install boilers of all sizes, but we're mainly focused on this scale of boilers, the 1 million plus. And to be able to work with a company like Schmid is been very important for us, because they're looking at the boilers as an ongoing something, that continuous improvement, as opposed to we've invented this boiler 20 years ago and you can still buy it today, just basically like it was, with maybe slightly better monitoring or something, where these guys are making modifications to their boiler line. Each year there's new changes and things they've learned, and they're truly into the research side of things. We were very impressed with that, and visiting them over in Europe and seeing what they're all about. One of the keys is that they actually have gone ASME, and they have that capability for bringing boilers to the United States. So there's multiple criteria you look for. Well, one thing, can we even bring it over? And has it been proven as well as something that can, that is durable and, truly a viable product, and all, they check all the boxes, and we're thrilled to be partners with them. So this is, we've got a number of installations, and come January, February, we should be planning. We will be showing a number of installations, reviewing different projects that we've done that will be featuring these Schmid boilers, and we'll have another chance to see this, to learn more about it and to see it from a slightly different vantage point, maybe with Mark and some of our installer people that could give you further insights into the operation and setup of these boiler systems. And even from the Swiss side, we're going to have some engineers, different people be speaking about this as well. So all those different perspectives really make a big difference. So watch for us. You'll be able to get this on YouTube in time, and watch for that. We'll give us another week. I think last week's is not up there quite yet, but everything else is that we've had. All these webinars are now on YouTube as a video on demand. So you can watch this anytime. And like I say, within a week, we should have this up. Marcel, did you have something more?
Yeah, just wanted to add to saying that maybe better than a lot of words and presentation is just come and see the references. There's about 10 Schmid boiler references in New England, and yeah, go and visit them and speak with the operator. And I think that is the best way to be convinced about a product and the technology.
You can also talk to the guy that does the maintenance and Froling Energy. He's an expert in seeing what breaks and what doesn't break and all that. He's got the track record. So yeah, there's a lot of those are great experiences. I think to talk to the man that owns one. That's the old phrase from somebody. So if you have any questions, if you'd like to have copies of the slides, and I see people have asked for that, we'll be very happy to send them to you. So we'll do that. And the slides, that would be more of a PDF on a printable sheet. You can always write to me, jim@frolingenergy.com, and I'm happy to send you that. If you've got more questions you'd like me to pass on to Marcel, I'm happy to do that as well. So I thank you for watching today. We don't have any more webinars scheduled until January, February. We'll be announcing those as time goes by. So thank you very much for attending today. And we'll be in touch. Have yourself a
Jim, I wanted to thank you for keeping us connected during these COVID times. I think they were very helpful presentations here, and thank you for putting the effort and time to get people together here. We really appreciate it, Jim.
Well, that's wonderful. I'm glad you love it, because we usually do lunch and learn. So you have to bring your own lunch for these, but we love getting the word out, and it's important. Thank you.
Appreciate it. Thank you very much. Thank you, Marcel.
Good.
Thank you.
All right, everybody. So goodbye. We'll end this meeting.
Bye-bye.
Thank you.
Thanks, Jim. Thanks, Marcel.